let me read the next question here. At infinite dilution, the equivalent conductances of sodium acetate, HCl and acetic acid are 91, 426 and 391 mole centimeter square per equivalent respectively. At 25 degrees Celsius, the equivalent conductance of NaCl at infinite dilution will be. So this question is from the concept Kohlrausch's law of independent of migration of ions. So the meaning of this Kohlrausch's law is that the limiting molar conductivity of an electrolyte. The limiting molar conductivity of an electrolyte can be represented by the sum of their cation and anion. So that is, limiting molar conductivity of an electrolyte can be represented by their sum of their cation and an ion. So it can be written like this. So from this Kohlrausch's law, based on this law only, this question is going to be solved. First, let me write what all the given things is been given here. They have given the equivalent conductance of a sodium acetate here, that is limiting conductivity of this sodium acetate CH3COONA, given by the value. It is how much here? It is 91 is given. Okay, and for the limiting molar conductivity of HCl is also given here. It is 426. For acetic acid, limiting molar conductivity for acetic acid is also given. That is how much? 391. So the unit is mole centimeter square per equivalent. The unit is same for all the three here. And they are asking for the limiting equivalent conductance for what it is? NaCl. We have to calculate this NaCl. And just now, as I have said the law here, it is the independent migration of ions, the sum of independent migration of ions has to be taken, individuals ion. So that means that for NaCl it will be limiting molar conductivity of Na plus and limiting molar conductivity of Cl minus has to be calculated. So limiting molar conductivity of NaCl has to be calculated here. To calculate this one, we have to take the individual ions of these given acids here. So to write this one, to get this limiting molar conductivity of NaCl, what we can do is that we have to get only NaCl here. I'll take the values of what here? Sodium acetate. I'm going to add the ions of the sodium acetate plus limiting molar conductivity of HCl minus limiting molar conductivity of what it is? Acetic acid I'm going to take here. So how I'm going to get this type of equation here? So let me solve that one firstly. To get this limiting molar conductivity of NaCl, let me split out this individual ions, that is limiting molar conductivity of acetate ion plus limiting molar conductivity of Na plus ion plus limiting molar conductivity of H plus ion plus limiting molar conductivity of Cl minus ion minus limiting molar conductivity of acetate ion, that is CH3COO minus of limiting molar conductivity of H plus ion. So to get this NaCl, we have to take like this. So now that is CH3COO minus, which is of plus here, and CH3COO minus, which is of minus here, both will get cancelled, and H plus ion and here it is minus H plus ion, both will get cancelled. So that finally we are going to get what it is? Limiting molar conductivity of NaCl as limiting molar conductivity of Na plus minus, that's plus limiting molar conductivity of Cl minus. So to get this one, firstly we should be knowing which acetic acid or which acid has to be subtracted and which has to be added. From this we got to know that acetate, sodium acetate and HCl values has to be added and this acetic acid value has to be subtracted. So from that I am substituting the values here for the calculation of limiting molar conductivity of NaCl here. Sodium acetate value is given, that is how much here? It is 91. 91 plus HCl is given, that is 426. 426 minus of, so when we do the subtraction, then only we will get the answer for what it is, NaCl minus 391. Okay, so our answer is going to be 126. 126 will be the answer for what it is, limiting molar conductivity of NaCl here. So basically we should be knowing which values has to be subtracted and which values has to be added so as to get the final value of our limiting molar conductivity. So from solving this question, we got the answer as first one as the right answer for this question.